Hello guys, welcome to my channel again. In this simple video tutorial I will show you how to do gears mating. So I simply go to the assembly, open it, wait for the assembly being open. So I will use the gear ratio of almost 4. You can also choose your gear ratio of 1, 2, 3, 4 or what else you want to choose. So please, my assembly is opening. So now after opening of assembly, an insert component dialog box appear. We simply have to cancel this dialog box and cross this. Simply go to the front plane, sketch, choose line command. Since I have to use the gear mating ratio of 4, so I will use the appropriate length. So I will draw a line of almost 125 millimeter, because 25 multiplied by 4 is equal to 100. So I will choose line of length 125 millimeter. It is 138, 125. I will make this line segment and this point a midpoint relation. Here it is. Now it's done. I simply have to select circle command, go to this point, draw a circle of radius 100, draw another circle from this point of radius almost 25. So we give the dimensions of 200, because 100 radius, 200 diameter. And in the similar way, 25 radius, 50 millimeter diameter. So leave this dimensions driving. Okay, wait, I think I have something wrong. It has 200, and no, if we give dimensions to this smaller circle, it will become 50 millimeter. So if we make this dimension dry one, okay. So after doing this, simply exit, go to your design library, toolbox, add your toolbox. Now my toolbox are opening. I will use NC metric, American National Standard Institute metric SI units. I will go to power transmission, gears. So I will use spur gear. So now my gear is opened with its, please wait, no, the command or everything is open. I will, since we know module is equal to diametral pitch divided by number of teeth, so we have chosen for larger circle a diametral pitch of 200 millimeter, radius of 100 millimeter. So the module for the both mating gears will remain same. This is the module will remain same in case of 1 gear ratio 2, 3 or animals. The module and the diametral pitch will remain same. Otherwise pitch diameter is now 200 millimeter for the larger circle. I will choose module of almost 4. So for 200 I will choose number of teeth as 50. So 50 multiplied by 4 is equal to 100. Now I am done. for the larger gear. Don't insert another gear, simply click cancel. You can insert another gear if you have to choose a gear ratio of 1:1. So don't draw this smaller circle, draw circle of equal diameter and equal radius and choose equal gears. Now I will again go to the design library. Spur gear is already open. I will simply drag another spur gear. Now another box will appear. Since I have chosen a module of 4, so for 25 for 50 millimeter diameter, what I have to do, I have to simply choose 12 number of teeth. 4 12s are 48. So there is an error of almost 2 millimeter. We will set this error later. Wait and watch. Face width 10 millimeter, nominal shaft diameter 35. We will simply go and we will choose a 16 or anything else you can choose, so it will become less. I will choose 10 millimeter. No, it is very much smaller. You can choose another module to fix the exact gear ratio. No, the gear ratio will be the same. I will show you. Simply select this face and go to assembly, mate this face of front larger gear with the front plane. Oh, sorry. If I do this, the first component is already fixed. Now you can see it is F shown here. This is fixed. I will make it float. Then after doing that, I will mate the face of this gear with the front plane. If the component is fixed and you will do this, this will create problems. So now the face is mated. I will simply mate the front plane of this smaller gear, face of this smaller gear with the front plane, and these are coincident mates. So now they are almost maten. Now you can see that gears are mated with front plane. So what I will do, I will mate gears concentric mate this point of line segment, mate concentric mate with this circle. Now it is almost, we are near to our objective. I will simply drag this gear away and I will zoom it. I will mate this point concentric with this circle. No, you can see that we are very much near to our objective. So choose front face. Now you can see that teeth are already aligned. You can align by moving them in such a way that here you can see. So teeth are aligned now. Teeth are aligned since. So what I will do, I will hide this sketch. I will simply Control 7. I will simply zoom. Now I will do gear mating. Mate. Close the standard mates. Go to advanced mates. Here, go to the mechanical mates. Here you can see the gear mates. So gear mate this surface. Zoom this surface with this surface of tooth. No, these are the two. You can see teeth diameter 56 by 200. So the exact 4 ratio is not obtained. So what I will do, here 50 millimeter ratio and here 200 millimeter. Now I can exactly obtain the gear ratio of 4. No, I am almost done. Gear mating done. So control 1. Now you can see when I rotate this gear, it will all rotate. So when I give one rotation to this gear will rotate 4 times. I will show you. Simply go to the motion study, choose motor and choose this gear, rotary motion 100. Instead of 100 we can use 4 rounds per minute. Okay, now we will increase the length of our animation, time length. I will go to 30 seconds, because in 30 seconds this smaller gear will go through 2 revolutions and the larger gear will go through only half a revolution. So see, when I play this animation, you can now see that in 30 seconds this smaller gear will go through a revolution of 2 revolutions and the larger gear will go through a revolution of one half revolution. Guys, there is a problem here because I haven't chosen the exact module. So if you choose the exact module you will not face any problem here in teeth coincidence. I hope you liked my video. Thank you for watching this tutorial and welcome to new members to my channel. Please like and subscribe. Thank you very much. I am going to save this assembly.